with we took more than 10 minutes, right? Yeah. Okay. So let's do it with K and N. K nearest neighbor. So usually we call the most frequent one. Okay. So here we don't need to do tuning or validations. It's direct, straightforward. Look, for example, here we have here 3 classes, and this point here, the pink color here, X and Y. What do you think is belong to which class? Blue, red, or green? So to answer the questions here by using nearest neighbor, what is it? The first one? The first, what do you do the first one? We take all the green one, we calculate the mean is here, right? We take all the blue one, we calculate the mean here. All the red one, the mean here. And the minimum, or the closest to it, is our class. But here, we don't do this. We take the data as it is. We calculate, for example, here, let's take K5. What does it mean? Take the K nearest point, or dot, or positions. What we have here? 3 are red, 2 are green. What is the majority voting? The red one. So according to K5, we can assign the new point to the red class. Is it clear? If I want to change this one to K equals to 3, what should be the class here? Green. Is green. So which one is better? The green. We cannot say. We have to do over all the data and see which one is the best accuracy. So like this we cannot say. We cannot tell. On single point we cannot say. Okay. So what we do? How we can calculate here? Take, what does mean? K is number of data. Look, we identify K, right? Capital K. Small K1 for the class 1, K1. K2 for class 2, class 3, and so on. When we normalize them by K, what we take them, a maximum is my class. Is it arc max? Clear? If we are in the binary, it's better to call it -1 and 1. Why? If you're doing this one here, if it's -1, -1, -1, we're adding them. If it's positive, means we are more in the positive class. If it's negative, we are more in negative class. For example, here, let's remove the blue one. We have only 2 classes here. What should be for the big one? Here is class 1, and this is class -1. What should be here? 1, 1, 1, -1, -1. If you add 5, you get minus. So belong to the minus class. So just the way how you can simplify. Here, for example, 3. Let's do it here. For K equals to 3. What is K1, K2, K3, please? So we are looking for the small circle, right? For the green one, what will be here? 2 out of 3. For the red one, 1 out of 3. For the blue one, 0. We don't have. Right? So what will be here? 3 out of, here for the, let's take for 5, sorry. Let's take for 5. The big one. What is the red one? 3 out of 5. The green one? 2 out of 5. The blue one is 0. What is the maximum? 3 out of 5. So we can assign to children. Do you find out any problem about these techniques? Imagine here we can find 2 red and 2 green, certain cases. Which one class you would decide? Sorry?
You have to change the K value.
Yeah.
If you change the K, you're still having this issue.
The K
Because
should
for
be
every K, I can find example when there is an issue.
Random. And
We can do random, yes.
K
Exactly.
size, that's also a problem.
Sorry?
If we increase the K size, for example, to a big one.
Yeah, one way, increase the size, yes.
We may use weighted distance.
Exactly, this we're coming to it. Thank you, exactly. Okay, so look here, for example. Here I do a different scenario. K1, 2, 3, and 4, 5, and so on. What you can observe here in this curve? I'm increasing the K, right? This is for the smallest one, and this is for the biggest K, for example. I can do more big. What you can observe? Yes?
When we increase the K, the model will overfit.
Opposite. You see, this is the biggest K K. This is the smallest K. So if I say which one is overfitting, I have to say this one. Another observe. What is the observation about the boundary curve? It's getting smoother, smooth and smoother, right? So here, and if I increase it, become like a line. Get the idea? So if you have data is well separated, you can increase the K. But if the data is not well separated, try to take the average of them, okay? How we can look, for example, here. I have this case here, 2 star and 2 circle. Which one I have to decide is an issue. Maybe here we have 2 star, 2 square, 2 circle, 3 classes. Which one I have to decide? So there is an issue. As you said, we can look for
the 2 stars and 2 circles. They usually don't use K for even number.
even number. Look, for example, let's take here 5, and inside we have a square, 2 circle, 2 star, and 1 square. Which one is it? K is 5. So still an issue, right? You see, 2, 2, 1 in multi. K odd, you take it when we have in binary. Here, yes, we are always avoid binary, yes. If you have 2 classes, yes. But multi-classes, we can always have an issue. Okay? So he said we can take K odd number, 3, 5, so on. But this is true only when we are in the binary classification, not when we have multi-classes. Okay, so what we can do here, look thing. We can look about the distance among the K here, how close they are to the new data. Look, for example, here. We can say here that this one and this one are close to each other, right? But overall, what we do, we calculate the distance for all of them, and I will take the one away. What does that mean? I want to see how close it is. What does it mean? 1 out of distance. Clear the idea, right? So what will be here? More the distance is small, more the weight is? The weight is bigger. Clear. So what we have, either we do 1 over d, or either you do the exponential minus. Which one is better? Here there is an issue. You might divide by 0, right? So it's better to use this one to be in the same side. And later on what we do, we calculate the weight. More the weight is higher, more is our class is clear to be 8 on T5. Is it clear here? So this will be my disclaimer. What does it mean here? Take the weight for the green, divided by the total weight. Take the weight of the red one, divided by the total. Take the blue one, divided by the total. The highest value of the class I, we will assign the new data to class I. Clear?
Is it the same way when we try to train a module by using CNN, let's say, this is the right way to find the weight?
Yes, exactly. Yeah.
Yeah.
But here the distance I propose only 2, but you can do more. Okay, so this is the way how we can do it. If we are in the positive, negative, just put sign negative and minus in the binary to be easy to classify positive or negative. Yes. Okay. How we can say about classify? It's simple.
Doctor,
Yes.
What is the best sample size in terms of the data? 10%, 5%?
The size of your data, right?
Yes.
To do KNN, I have no idea. You have to think about it. Okay, so we have if the data is bigger, but what is also about the dimension or number of features? Yeah, honestly, let me think like this. I have no idea. I have to think about it. Yeah, it's a good question. Yeah.
Depends upon the scenario.
If the data is small, you mean is it possible to do this one or not? If it's small, okay. If the data is big, it's better to use PDF or a density as we did before. But if the data is small, far to each other, because if it's small, maybe the data maybe it is not about the size, but it's about the density, how the data are close to each other. I think so. But honestly, this type of questions is not always easy to answer. It's really, you have to test, or you have to optimize, and you need a lot of math. Okay, look, it is very effective. Non-linear decisions, anything non-linear, we can do it easily. However, we have to store all your data. So So do you think this one, it is the right thing to do it on IoT system? You have to, a lot of memory, right? You have to store all your data on it, so it's too much. Another thing, in terms of computational, you have to do a lot of calculation. Look, for example, if you have new data, you have to calculate the distance for every single point. What is the complexity of order? N. So it's a lot of calculation. Memory and calculation. What does mean calculation? It's battery. If you have something, IoT or something, you have to save the battery here. So there's a lot. So KNN, it is good sometimes, but there is a lot of memory. What does mean memory? The price is increasing for your devices to do it. So you have to think also about this later on. KNN may fail in presence of duplicate. If the data is duplicated, some people they use in data augmentation or upper sampling, they repeat the data as itself. So this is not the right thing to do always. Finally, it is another problem how to choose K. So you have to do a lot of Ks and you have to find the best way. For example, if you
Multi-class problem, doctor, it mixes the features. If
Yeah.
there is multi-class problem, even I found it very clear in my case. When there are 44 classes, then I did classification.
Yeah.
So even for small value, okay, just round about 60% accuracy. Around like that.
yeah, so did you try the weighted KNN?
Yes.
You want to do it also, right? Yeah, so maybe it's not too explain. For example, here, if you have data, you put K5, you get 90% accuracy. You put K10, you get 95 accuracy. Which one you have to choose? Give the same accuracy, one for K5 and one for K10. Which one you have to choose?
5.
5, the minimum. Why 5?
Less computation.
Less competition, thanks. Yeah. Because when you calculate the distance, what you need to do else? Sorting.
Yes.
Yes or no? For example, you have n data. You have n new point. You have to calculate n distance. And after you're doing n distance, you have to do sorting them. What is the complexity of sorting algorithm? The best one?
N log n. Yes.
N log n. Plus n to be n log n. So you see the complexity is, imagine if n is huge, so it's a lot. Okay, so, okay. I finished this one. I try to, now we do the base classification. Look, for example, good movie, include Tom Cruise. Just example, I took it from online. And good movie, Tom Cruise is absent. I give you 001, 01. Tom Cruise in a random chosen movie is 0.01. What is the probability Tom Cruise is in the movie, given that movie was not good? How you calculate this one? You don't have to solve it, or in the, so I can do it with the conditional probability, but most likely this one is actually can solve the issue easily. Okay. Which one comes first from the given information? The movie is good or not, or Tom Cruise is in or out?
Good enough.
Think again. Okay, which one comes first? According to the three position here. Do you think the movie or Tom Cruise? Okay, how to answer the questions? Giving that, thanks. So the giving that is Tom Cruise. First, let's do it here. Tom is in, Tom is not. Yes? What will be the probability Tom is in? From the third line. 0 point? The opposite is? 0.9. Clear? Next one. The movie is good? Or the movie is? We put it G better here. Good, not good. And here is good, not good. Okay. What is the probability of this one here, please? This is the probability of Tom is in. And this is the probability of Tom is not, right? What is this transition here? Transition. I was in the airport. Here, I'm going to this one, right? So it should be the probability of giving that Tom is in. What is the probability is good? Is it giving here? Tom is good. Good movie. Is 0 point? Here, what should be here? The both 001? No, 101 here. Yeah, 01 and here 0.9.
It's the first.
Look at it's the second line. Look at the probability. Tom. Tom is absent, right? Is here. Okay, so this is good and Tom is in. This is the probability of Tom is absent and good moving. This one is 0.1. Correct? This is 0.9. And yeah, include move. And here moving is good and Tom is in is 0.01. And this is 0.9, right? What are the questions now? The question is the probability of Tom giving that the movie is not good. What is the formula for the giving informations? Giving the probability of intersection, right? Divided by probability of not good, right? Probability of not good, what we have? Two scenarios. Can be this one or can be this one. Yes? Correct? So what should be here? The first the first path divided by the sum of the two paths. So what should be here, please?
Doctor, you cannot use the next one because the second one is for when Tom Cruise is out, absent. And here it says when Tom Cruise is in the movie.
Yeah. Okay. Do you agree with those two things?
Yeah, but
Okay. This one, do you agree with this one?
yes.
Okay. This is the question, right? You agree until now?
No, because the G lost. This does not compare with the statement. What is the P Tom Cruise in the movie?
Here, talking about this one, right? Okay. The probability of the movie is good, given that Tom is absent. Where is it here? The Tom is absent is here. The probability is good is yes. This is the Tom. The first one, Tom is included here. Tom is included is here,
The movie is not.
and the movie is not good.
We can just.
And here the movie is good. So this is 001, and this is the opposite.
Okay.
Yes, correct. Now, Tom is absent, the first one. Yes, no, second one, sorry. Tom is absent, and the good movie is here, 0.1, is correct.
But
And this is the opposite.
yeah, but in the statement they say when Tom Cruise is in the movie.
And the question is, Tom is, okay, so okay. Tom
So P was
is in the movie, given that the information, you see, given that the movie was not good. Can you find it directly from here? It is, you see here, T is here and here, but I did the inverse, you see, I flip it. When you flip it, you cannot calculate it here. When you have something like this, means this is come first and this comes second. But now I do the inverse. Among the movie that Tom is in, among the movie that are not good, what is the proportion that Tom was in? So we do it here. T intersection G bar, what is it? T G bar, what should be here? 0.01 times 0.99, right? Divided by the probability of the movie is not good. There is two cases, two scenarios. 001 times 0.99 plus 0.99 times 0. And we can find the answer here. So we can do it directly by using here, but if you do the T, it will make it easier for you to understand. Okay? So this is just introductions that I want to use. Bayes thing. Okay, Bayes rule.
Can we use bias as well?
Yes. Hey, I'll come to it, yeah, exactly. Here, just give you an idea how we can solve it. Now I give you another idea, different idea. Look at probability of A intersection B can be written as probability of A given B times probability of B, or this way. Same thing. A and B, we can say joint probability, A and B. And A given B and B given A, we call it conditional probability. Clear? P and A, we call it prior probabilities. Bayes' rule is probability of A given B is the probability of intersections over probability of B. And probability of the intersection is this or this, up to you, which one you can choose. So usually I use this idea, look at I have a data. Yes, the data is coming. I say, giving this data belongs to which model? So what I need to do, look at, giving the data, I want to calculate the probability, the model. What does mean the model? Mean the class. Giving the data, it belongs to which class? I use these calculations here. I have the model. I can calculate the probability of data. The model, I have it, is the probability of the class and probability of the data. And here, it will be easy for me. Now we can do the classification. What does it mean? Give me the data is given. From the looking to the data or seeing the data, what is the probability that belongs to the class 1 or class 2 or class 3 and so on. So this is the main idea. So look please here. I have class 1 and class 2. And I have a new data, I want to classify it, X. What I want to calculate, the probability of X given the model class 2, probability of X given the class 1, and then we calculate the two probability. The highest is my model. As simple as that. Clear? Look to here. According to this curve, it will be this the boundaries for me. Anything less is red, anything is upper is blue. So how to calculate this one here? I use the base idea. A given this, I do this one here. And this is easy. If I have the model, I can find the PDF, probability density function. So it will be easy to calculate. So at the end, I have to calculate this here and to compare this versus 2. The highest is my model. We are 2, compare with the 2. If I have K classes, I have to compare with K classes. Okay? So look, for example, here we have two things. What should be the model here? The misclassifications is the blue area. So this is the area. Anything in the blue area, I will, maybe there is misclassification, but anything outside, we can classify it in the right way. And here, there is one critical point that we can do. For example, it depends on the complexity of the class. For example, here, the right class, it seems a little bit complex than the other one. Here, it's more complex. You see here, there is no single threshold that you can do. Meaning, this area is class 1, this area is class 2, and so on. For example, here, in this area here, what will be the class here? Blue or the red one? Here. Blue or red? How to answer the questions? Look to the probability. The probability of blue is this. The probability of red is this. Who is higher? The blue one. Here. The red one. Here is the blue one. So usually what we do, we calculate the probability here. Look, I have 4 things. Give me X, I want to calculate the probability of the class I. This is the target. To calculate this one, I need this, and this, and this. 3 of them to calculate them. We can do it directly, or we can use the likelihood. What is likelihood? The one who is using statistic, we use it maximum likelihood. Yes, model. So instead of using this one, I just put logarithm. Okay, so don't be scared. This one here, the same thing here. Why I use logarithm? If this is bigger than this, the log of this is still bigger than this because logarithm is bijective functions. Same. What do I mean bijective functions? Bijective functions? Always increasing or always decreasing, or we call it one-to-one functions. I'm just giving details for those who want to understand why. Okay, here for example here, let's try to do another idea. You have 100 movie and you have 100 book. And they want to classify them according to the types. Science fictions, actions, drama. Okay? And for example here, there is, for science fiction we have 45 movie and 30 books. Here we have 60, 20. Here we have 45, 50. If I pick one randomly, what is the probability that it is science fiction? What is it? Okay. Science fiction would be 45 plus 30 divided by the total. What is the total here? 250. If I pick one randomly, what is the probability that it's a movie? Okay, I have 250. I have 150 movie, 100 book. If I pick one randomly, what is the probability to be a movie? 50 over 250. If I pick one randomly, what is the probability to be a book? 100 over 250. So you see here, I will, at the beginning, I will do disgregation between movie and book. We call it pi 1 and pi 2. What is the probability that it is science fiction, given that it was a movie? So for the movie, how many we have? 150. Among the 150, there is only 45 is movie. So we can calculate this one, right? I can do for the others the same way. Yes? Clear? Did you understand this one or not here? The conditional one. For example here, what is the probability? Action giving his book. So now I'm talking only about books, okay? Those books, if I pick one randomly from the book, what is the probability to be action? We can see at the book what we have. 30, 20, 50. So it will be 20 out of 100. Okay? So after calculating this one, the question that I want to answer here, if you give me features of these things, it is actions. What is the probability that it is a class movie? So here I have two classes, class movie and class book. I have features. What is the features? Tell me the type of this. Is it science fiction or action or drama? Based on these features, and these features have three types, what is the probability that it belongs to the movie? What is the probability that belongs to books? So we have two actions. So what are you thinking? How to calculate this one here, please? I give you 1 minute, please try to do it. What is the probability that the movie given actions? In classification way, the features equals to action. What is the probability that it belongs to the class movie?
So 45.
We apply the base rule, right? So how we can do it together here, please? The probability of movie giving that action, right? What will be the probability of action intersection movie divided on probability of action, right? Okay. What we have about this one here? Intersection, what will be here? Movie times the probability of action given movie over probability of action. Can you please do the calculation, please? What is the probability of action, please? We have it, right?
Yes, action given.
Action, what is action here? Action is 2080 out of 250, right? What is the probability of movie? 0.6, right? Time probability of action given that is movie. For the movie, I have 60 out of 150, right? Yes? Imagine in calculation, I will not do it. Imagine it's 0.6. What do you think? Do you have to classify it to movie or book? Because I have two classes, right? If the probability is 0.6, what is the probability of the other one? Book action will be 0.4. So we have to classify it to movie. If we get here 0.3, means the probability of book given action will be high. So we have to classify it to the book. Okay? So here we do the calculations. Sorry? In this case is, we cannot decide. Take randomly. Yes. Head or tail in this case. But it will be very rare in the real data to find something equals. Really. Okay, so in this calculation, what we have? Look here. A book, science fiction, is 0.4. So here, the feature science fiction will be classified to the book or movie. Are you sure? Please, here, this line here. Probability of book giving science fiction equal to 0.4. Given this data science fiction, is it most likely to be a book or most likely to be a movie? It's a book. Because a book would be 0.6. So 0.5 is our threshold. Because we are in binary only. We don't have multi classes. Sorry? Sorry, the book, yeah. Sorry, yeah. For the book, 0.4. So this one we have to classify a video. Second one here. Look at a movie giving action, 0.75. A book giving action is 0.25. So giving the features action, which class is? Book or movie? Movie. And we can do for the others. So here I did it for simple idea. Now let's try to make this one more general to multi-data. So we come back to this one here. We calculate the PDF. Okay, so we have to calculate this one. Look at, we calculate two different probability. You compare this is bigger, or you can do the ratio, or you can do the logarithm. Doesn't matter, all the same thing. But most likely we use the logarithm. Why? Because Gaussian distribution is exponential minus something. To put this one down, we need to use a logarithm. Just for a calculation to make it easier, nothing else. And also because logarithm is bijective functions. Okay, okay, so now the questions, I can reformulate the question is how to estimate the probability density functions. Think with me before giving the solutions. You have the data, right? How to estimate the PDF, please? Or the histogram, how to do it? Try to think. You have the data, right? How we want to estimate the probability or the histogram. But in easy way and very effective. Did you hear about kernel functions?
Yes.
Kernel functions? Okay. Look. But do you have any other idea that you can? So now it is idea how to create better kernel functions. Let me go to giving details. Look, this is kernel functions. Can be different size. You have your data, right? Data. Every single data, put kernel function on it. Every single data, put kernel function. When you do the summation, it gives you a very nice curve. Example, I can do different way, okay? I have this data here, look, the dot red. Every one you put a data, when you add them, look what you get. You get a curve. But this problem of this type of kernel, they don't take in consideration the other point around it. How close are? Is it dense or not dense? So this is a direction of research on this. Okay?
Is the kernel, is it like a filters?
Like filter, yeah. It can be filter, can be as we did kernel for the PCA and SVM. It is the way how we can estimate PDF or the way how you can, because from the function we can generate other features or we can generate a PDF. A kernel is like the core of something. Yes. Yes, not parameter, yeah. But we can make it parameter of the kernel. We can put parameter inside the kernel. Too. Yeah. So in this case, okay, if you do the Gaussian, you get this one. If you do the triangle or a rectangle, you get what you get. But which one is better? It's up to you. Do you want to make it smooth function or not? Here, single one. Let's do it now in 2 dimensions. You can put cylinder, you can put Gaussian 2 dimension, you can whatever shape that you like. Okay? And if you add them, you will get estimation roughly to your PDF. This we can call it non-parametric functions. But now let's go to another things. Every cluster I will estimate it to this. What is this one? Gaussian distributions. Yes? Single one. There is other technique in this, they use multi-Gaussian distributions. Okay? So here we have Gaussian distributions. I want to estimate it here. What do you need, please? We need 2 things. We need to know the mean of your class, and we need to know the covariance matrix. And we know how to calculate, right? We did it many times. When you have the data, what is the mean, what is the covariance matrix? So at the end, I need to estimate it, and this is my function g. More the g is higher, more is likely to belong to this class. Okay, same way. And this we call it again quadratic one. If there are the covariance matrix, it is diagonal, we're coming back to the minimum distance. If the covariance are the same, we're coming back to the LDA, discriminant linear one. If it's not, we're going to the quadratic, and it looks like Mahalanobis distance, but just with those few constant adding. Okay, so we are always quadratic, linear, to the mean nearest point, directly. I will not go in details, you can read it, okay? It's linear and so on. I try to give here, for example, different scenario. This is, look, for example here, if they have the same covariance matrix, what will be the boundaries, please? Linear one, right? If they have different covariance matrix, what will be here? Quadratic. And here still quadratic. You see here? But here they are both diagonal, but they are not the same. Here is double this one. The values one is 1, the other values is 2, but still quadratic. Here, for example, I have the red and the blue one. I create the PDF estimations either by using parametric Gaussian or non-parametric by the kernel. And you look here. If we do the cutting, you cut at every level. You see the circles. The circle is when you cut in or what's called horizontal plane. So what does it mean here? You see here, this is your boundary. You see here, the boundary is okay. Why? Look at which one has the gravity bigger, the one upper or lower? Lower. Why? The values is bigger. Okay, how to estimate the mean and the covariance matrix? Take here, xi is the data for the class I. From the class I, we can calculate the probability of it, is n the size divided by the total size. We can calculate the mean, take all summation divided by ni. We can calculate the covariance matrix, exactly as we did with before, PCA or LDA. We have mu1, mu2, sigma 1, sigma 2, and so on. Look, for example, here, this is the real value, and this is how we can estimate. You see, the estimation is always closer. I forgot to charge my laptops. So how we can do the estimation here? The estimation that I did it. Those who take the course of statistics, we have to say, the estimator, is it biased or unbiased estimator? Okay, before I restarting again, I try to do here. Look, for example, please. I try to review quickly here. The simple is quite easy. Look, for example, here. I have a density f of x with a parameter theta. Yes, this is the probability. Okay, look, for example here. I have a sample size, sample x2 until xn. So based on the sample here, can you estimate theta, please? Can you think with me?
Yes.
Yeah, you have a density probability with the parameter theta. And you did a sampling, you get x1, x2, xn. Those are given. The question is, can you estimate theta? Maximum likelihood. But for those who didn't know what is maximum likelihood, what we do here? What is the probability to get x1, please? What is the probability to get x2? What is the probability to get xn? This one, right? Okay, so now, if I do the product, this is the probability to get this sample. So, how to estimate theta here? Is the idea, I need to maximize this one in terms of theta, and will be your estimator. Why? Because most likely, theta to estimate it is this, give me this, the most likely to get, or the mode if you want. So what will be here? You have the product, you find the maximum, you do the derivative of this one. But in terms of derivative, how many? You have, imagine you have 20 functions. How you can do the derivative of 20? Remember, in calculus, what is the derivative of the product, please? F prime g plus fg prime. Okay, if you have f1, f2, f3, what is the derivative? It gets crazy, it will be a long formula. If you have 20, it's really difficult, right? How we can solve this issue? Make Yes? So the problem is coming from the product, right? What we do? I introduce the logarithm. Log of the product of f, which will be here, the sum of ln of f. And the derivative of the sum, it's easy to deal with, okay? So this we call it maximum likelihood in 2 minutes, but I'll not go too much in details. We did it in the statistic for those we are doing. I prove it here again, for those who want to get the proof. I will come back to here. Okay. So at the end, what will be? It's just this function as we did before, the same thing. Mahanut distance. So, okay, that's all. Clear? We take a break for 5 minutes. I will do another idea. So it's too much information, I know, but we have still only another class next week, and we are done, right? I try to give as much as I can, but don't worry, it will be not every assessment will be. I'll give you how we can do a mock exam about the final exam. Okay? Yeah, you can check. Take the break for 7 minutes. Check your grade, and if there's anything, let me know. Thank you, Adnan. Thank you so much.